Hello, this is Miss Moore, and today during chemistry we're going to discuss the mole. Specifically, we're going to talk about moles to number of molecules. Today's essential question: how do you convert from moles to molecules? Okay, for today's lecture you need to have your scientific calculators handy, so make sure you have those before we proceed. All right, first step is review of significant figures. All right, I know, your favorite. All right, let's do this. Every non-zero digit is significant. Okay, that first rule is really easy, right? So if I had a number like 3.211, those are all non-zero digits. They're all significant. So this guy has 4 sig figs. Okay, zeros between non-zero digits are significant. Okay, so 2, 0, 0, 0, 2, 1. Okay, all of the non-zero digits are significant. All right, the 2, and the 1. And these 3 zeros in the middle are significant because they are between non-zero digits. So in this case, we have 2, 4, 6 sig figs. Okay, another one. You could have 1, 0, 0, 0, 0, 0, 0, 0, 0, 2. Again, the non-zero digits are significant, and all of the zeros in the middle are significant because they are between 2 non-zero digits. So this number has 10 sig figs. All right. And last up, zeros before and after a decimal are significant as long as there is a non-zero digit somewhere before the zero. It doesn't have to be directly before, but somewhere before. Okay, so let's see. How about 0.00200? All right, so let's start with the easy one. We know that the 2 is significant because it is a non-zero digit. Okay. What about 0.00? Are they significant? This one is before a decimal. These 2 are after a decimal. However, there is no non-zero digit before them, so they are not significant. Okay. How about these 2 here? They are after a decimal, and there's a non-zero digit before them, so they are significant. So in this case, our significant figures are those last 3 there. So this particular number has 3 sig figs. Okay. Hopefully that brings some of it back to you. If you're struggling with this, relook at this, practice again. You've also got a whole lecture of this stuff at the beginning of your notebook. Okay, a calculated answer cannot be more precise or exact than the least precise measurement. So the answer should be rounded to the same number of sig figs as the measurement with the least number of sig figs. Okay, let's try a real quick practice problem. Let's say I had 3.501 and I multiplied that with 22.1. When I put that into my calculator, I get 77.3721. Okay, so now let's go back to our numbers in the question. We have 3.501, and that guy has 4 sig figs because the 3 non-zero digits are significant, and the 0 is significant because it's between 2 non-zero digits. And the 22.1 is made up of all non-zero digits, so they're all significant, so 3 sig figs. That means our answer needs to have 3 sig figs, because that's the least precise measurement. So we have 77.3. Those are the 3 numbers we're going to keep. However, we need to do rounding, right? The answer should be rounded. So if you remember the rounding rules, you look at the first number you're going to drop, in this case the 7, and if that digit is 5 or larger, you round up. So this guy is 5 or larger, which is going to make the 3 jump up to a 4. So our final answer would be 77.4. Okay, hopefully you kind of remember this. Sig figs aren't too bad. Just relax, review if you need to. Okay, we need to do a quick review of scientific notation and specifically how to do scientific notation numbers on a calculator. All right, so if you guys remember what scientific notation looks like, if I had a number like 3.00 times 10 to the 5th, this times 10 to the 5 does not mean take 3.00 and multiply 10 5 times or something, or multiply by 10 to the 5th. It means move the decimal. Okay, so that's really important. Okay, so that times 10 to the 5th means move the decimal. 5 times in this case. Okay, so now, is there a way to do this times 10 to the 5th on the calculator? Well, I just said that it doesn't mean multiplication, so you're not going to hit the multiplication button, right? All right, so I have pictures of a couple different calculators here, and hopefully you will find one that looks like yours. So if you don't have your scientific calculator handy, go grab it. Okay, so here are the two of the most common buttons. One would be a button labeled EXP. Okay, EXP means times 10 to the. Okay, the calculator on the right has a shift key button, so it's right here, the EE. So in this case, you would have to hit the second button before you hit the EE button. That again means times 10 to the, or move the decimal, right? Again, not multiplication, it means move the decimal. Okay, and then a few calculators have something that says times 10 to the n. Okay, that means times 10 to the something. Okay, you'll notice up here something that says, it's a little blurry, but 10 to the x. That's not the same thing. Times 10 to the n. That is the least common button. Most of them will be either the EXP button or an EE button, which is often a shift key. And a few of you might have the times 10 to the n button. All right, let's try a quick practice problem together, all using your own calculators. So if I had a problem like 2.01 multiplied by 6.022 times 10 to the 23rd, how would I put that in my calculator? Okay, well first I would put 2.01, the number, right? And then I would hit the multiplication button, and then I would hit the 6.02, the 022 button, and then once again this does not say multiplied by, right? So do not hit the multiplication button. This is where you're going to hit your EXP button, or possibly your EE button, or times 10 to the n, a few of you, times 10 to the n button. Okay, and then so what you're saying here is 6.022, and then you hit your EE, EXP, or times 10 to the n button, which means move the decimal. How many times? 23. And then their equals button. Okay, so if you guys could all do that, make sure we all get the same answer. I got on my calculator 1.210422 times 10 to the 23rd. Okay. Now to finish this up, we should look at sig figs. This guy has 3 sig figs. This guy has 4 sig figs, so our answer needs to have 3 sig figs, which are those 3. And the number we're going to drop is less than 5, so we just drop. And the final answer would be 1.21 times 10 to the 23rd. Okay. Now, if you were able to get that answer in your calculator, go ahead and move on with the lecture. If you weren't, go back, look over the calculators again, see if you can figure out this answer. All right, finally we get to the mole. Introduction to the mole. As you guys know, atoms are really, really small, which means even a very small sample of atoms, so a little pile of atoms that we could actually visually see, can contain a huge number of individual atoms. So we're dealing all the time with really big numbers. So we have this thing called the mole, and the mole is used to express the amount of a substance. Okay? The mole is the number of atoms in exactly 12 grams of carbon-12. Okay, let's go back to this amount unit. Some people get a little confused by an amount unit. It's just like a dozen. A dozen, it's a word, right? A dozen. But it means 12. 12 eggs, 12 donuts, 12 students, 12 dogs, whatever. Okay, so the mole is an amount unit. So the mole is a counting unit used for measuring the amount of a substance. And the number of particles in a mole is called Avogadro's number. Okay, and Avogadro's number is 6.022 times 10 to the 23rd molecules. So 1 mole equals 6.022 times 10 to the 23rd atoms or molecules, or anything, actually. 1 mole equals 6.022 times 10 to the 23rd atoms or molecules. By the way, to differentiate atoms and molecules, an atom is a single atom, right? Like hydrogen or carbon or whatever. A molecule is 2 or more atoms put together, like C2H4, H2, whatever. Okay, an atom is a single atom. A molecule is 2 or more atoms put together. All right, let's learn the steps for converting from moles to number of atoms. This is a very important part of the lecture. This is the how-to. The rest of it was background. Okay, so converting from moles to number of atoms. And I once again gave you the equality, which is 1 mole equals 6.022 times 10 to the 23rd atoms or molecules. So the example we'll be working with as we go through the steps is how many moles of NaCl is 5.92 times 10 to the 12th atoms. Now, we got a little bit of a problem here. NaCl is not an atom, it's a molecule. Okay. So, step 1. Rewrite the problem as a math problem. So start with what you know. We know that we have 5.92 times 10 to the 12th molecules, and if you want to abbreviate molecules, you can, as molic, equals, what are we trying to find out? How many, right? X moles. The abbreviation for moles is MOL. All right, so step 1, rewrite it as a math problem. Check. Okay, next step is we set up the grid, or the T-chart, and write the given over 1. So we know our given is 5.92 times 10 to the 12th molecules over 1. Easy enough. All right, the next thing we do is write out the equality or conversion factor that relates the units given in the problem. And in this problem, we have molecules and moles. And for today, you only have one choice, but of course, we'll be adding on more as we progress through the unit. So we have the equality 1 mole equals 6.022 times 10 to the 23rd molecules. Okay, and we've got moles and molecules here, and molecules and moles here. So that's the equality we're going to use for this particular problem. All right, next thing we need to do is put the conversion factor into the grid. So the conversion factor is this guy right here. Setting it up so that all the units cancel out. And then we solve. All right, so if we look at our grid, we see that we have molecules on the top. So looking down at our equality or our conversion factor, we have moles and molecules. We will put molecules on the bottom so that we can cancel out. And on the top then would go 1 mole. Okay. Let's take a moment to make sure our units actually do cross out, and they do. Okay. And then to solve, we multiply across the top. So 5.92 times 10 to the 12th times 1 mole is going to give us 5.92 times 10 to the 12th mole over 6.022. 22 times 10 to the 23rd. Let's get rid of this so we have a little bit more room to work. All right, so now we're going to stick this number in our calculators, putting the 5.92 times 10 to the 12th in the calculator first. And remember that times 10 there does not mean multiply by 10, right? You should not be hitting the multiplication button at that point. That's going to be your exponent or EE button. Okay, so if you guys could put it in your calculators and make sure that you can get the same answer as me, I got 9.83062105.6 times 10 to the negative 12th. And I got to put our unit back in. We still have the unit mole. All right, now we got to figure out sig figs. So we go back to our original problem. We have 3 sig figs here, right? And this one has 4 sig figs. So we're going to use 3 sig figs. And the number we're going to drop is a 0, which means it's less than 5, sorry. So our final answer is going to be 9.83 times 10 to the negative 12th moles. And you need to have the units in there. Okay. Not so bad, I hope. Okay, so a few hints to help you be successful in these mathematical calculations. First of all, always write the units and the atoms or molecules, really important. Go through all the steps. Don't skip steps. The steps are good stupid mistake blockers. It'll keep you, if you do the steps, even though it takes a little longer, you're going to get the answers right. Be careful and work neatly. Makes a big deal. Makes a big, big difference. And I suggest doing the calculations on the calculator twice to make sure your fingers didn't hit the wrong button. And lastly, check your answer with the question. Does the answer make sense? All right, so if you feel good about the moles, move ahead. We're going to do a couple practice problems. If you're not comfortable, go back, review a little bit first. All right, so we have 2 practice problems here. I highly suggest you hit pause, try to do the first one, hit play, see how you did. Then hit pause, try to do the second one, hit play, see how you did. Okay, so here we go. How many molecules are present in 2.9 mole of potassium fluoride, or KF? So we start by writing this as a math problem. We have 2.9 mole KF, and we're trying to find out the number of molecules. Okay, so next we're going to set up the grid. And in the grid, we're going to put our known, which is 2.9 mole KF over 1. All right, now we need to find our equality. We have moles and molecules, so the equality is the only one we're using today, which is 1 mole equals 6.022 times 10 to the 23rd molecules. Okay. And when I go to put this in the equality, I'm going to put this time moles at the bottom because we have moles in the top up here. And on the top we'll go 6.022 times 10 to the 23rd atoms. Okay, I'm going to make a point to cross out my units to make sure I did it right. And from here I'm going to multiply across. And when I did that, I got 1.74638 times 10 to the 24th atoms. I'm bringing my units with me. All right, and when I go back and check out sig figs, I have 2.9, which is 2 sig figs, and 6.022, which is 4 sig figs. So my answer is going to have 2 sig figs. Keep those. The 4 is less than 5, so I just drop. So my final answer is going to be 1.7 times 10 to the 24th atoms. All right, next we have how many moles of neon is 4.98 times 10 to the 22nd atoms. So we'll start with my math problem, which is 4.98 times 10 to the 22nd atoms. That's what I know, and I'm trying to find the number of moles. So next I'll write my grid and put my known in, 4.98 times 10 to the 22nd atoms over 1. And my equality, this time we have atoms and moles. So my equality is same numbers but different unit. We're going to use 1 mole equals 6.022 times 10 to the 23rd atoms. All right, because we have atoms. And when I put that in my grid, I'm going to put the atoms on the bottom so it crosses out. The atoms on the top. Okay. And we're going to have to multiply across the top and across the bottom. So I'm going to get 4.98 times 10 to the 22nd mole, because atoms is gone now, divided by 6.022 times 10 to the 23rd. From here I divide. And when I did that, I got a big old long number. I got 0.082696778. Okay, and if we look at the sig figs, we have 3 sig figs here and 4 here, so we're going to have 3 sig figs. The first 2 zeros are not significant because even though they're before and after a decimal, there's no non-zero digit before it. So we're going to take these 3. But the 9 is 5 or bigger, which means the 6 is going to round up to a 7. So we'll end up with 0.0827 moles. And if you want to put it in scientific notation, you can. So remember to do that. In scientific notation, we have one number before the decimal, 1 digit before, so we have 8.27 times 10 to the, remember, move the decimal. We had to move it 2 times to get it there, and because our original number is less than 1, it's a small number, so it's going to be -2, and I'm out of room, I'll put the moles down here. Okay, either answer will be fine. All right, that's it for today. Have a good one.